Okay, we're going to balance a few more equations as examples. So we'll start with this one. It's already been translated. And so, on the left side, I'll start with magnesium. There's 1 magnesium and 3 on the right. Since there's 3 of them on the right, I want to add a 3 in front of the magnesium on the left. This gives me 3 magnesiums on both sides. Remember, here's our dividing line, both sides of the arrow, both sides of the yield sign. You want to always save oxygen and hydrogen for last. So I'm going to go for phosphorus. There's 1 phosphorus on the left. This 2 distributes, giving me 2 phosphorus on the right. So I need a 2 in front of this phosphorus. So now I have 2 phosphorus on the left and 2 phosphorus on the right. I'm going to do hydrogen next. And because I have coefficients, I'm going to distribute the 2 and then I'm going to distribute it to the 3. So this is going to be 2 times 1 is 2, 2 times 3 is 6. So we have 6 hydrogens here, plus 2 times 3 is 6 more hydrogens there, making 12 hydrogens total. On the right hand side, we only have 2 hydrogens, and so because I need 12, 6 times 2 will give me 12 hydrogens on the right. So now I have 12 hydrogens and 12 hydrogens. Finally, I'll do oxygen. On the left, we'll say 2 times 1 equals 2. 2 times 3 equals 6 oxygens, plus 4 times 2 equals 8 more oxygens, and so when I add those together, I have 14 oxygens. On the right, I have 1 times 6, that gives me 6 oxygens, plus 2 times 4 is 8, conveniently equaling 14 oxygens, which means my oxygens are already balanced to begin with, so I don't have to change anything. My mole to mole ratio in this equation is 3 to 2 to 6 to 1. It's a 3, 2, 6, 1 ratio of magnesium hydroxide to phosphoric acid to water to magnesium phosphate. Aluminum plus sulfur yields aluminum sulfide, and the S's in parentheses just mean that these are each solids and it has nothing to do with our balancing. So here's my arrow. On the left side I have 1 aluminum, on the right side I have 2 aluminums, and so I needed 2 here to have 2 aluminums, 2 aluminums. On the left side I have 8 sulfurs, on the right side I have 3. The best thing to do when you have a number like 8 and 3 is to find their common factor. 8 times 3 equals 24, so I want to have 24 sulfurs on both sides. I will do this by having 3 times 8 is 24, and in front of this one, 8 times 3 is 24. This has changed my aluminums, however. Now I have 16 aluminums on the right hand side, and so instead of having this 2 here, I'm going to change it to a 16. You can always increase the value of your coefficient, you can never decrease it. So my ratio is 16 aluminums to 3 sulfurs to 8 aluminum sulfides. It's a 16 to 3 to 8 mole to mole ratio. Okay, now we're going to get into a few combustion reactions, and we'll find out in later segments how to tell when these are combustion reactions. So we have carbons on the left, 5, 1 carbon on the right, so I'll put a 5 in front of carbon. Now I have 5 and 5. I have 12 hydrogens on the left, and I have 2 hydrogens on the right. If I have a 6 here, then 6 times 2 will equal 12. So we have 5 carbons, 12 hydrogens on both sides so far. Oxygen, I have 2 on the left. I'm going to do some adding on the right. We have 6 oxygens here, plus 5 times 2 is 10 oxygens, making a total of 16. So on the left, I need a coefficient of 8. 8 times 2 will equal 16. So now I have 16 oxygens on both sides of my equation. So the ratio is 1 to 8 to 6 to 5. It's a 1 to 8 to 6 to 5 mole to mole ratio. Another example of a combustion reaction We have 4 carbons on the left, only 1 carbon on the right, so I'll place a 4 here. I have 8 hydrogens on the left and only 2 hydrogens on the right, so I'm going to put a 4 in front. 4 times 2 now makes 8 and 8. My oxygens on the left, I have 2 here plus 2 more, making 4 oxygens on the left. On the right, I have 4 plus 4 times 2 is 8. 8 plus 4 is going to give me 12. Over here, I don't want to add a coefficient in front of this compound because that'll change my carbons and my hydrogens. So here, I'm just going to say, well, I've got 2 of my 12 oxygens here, so I need 10 more right here. And if I add a 5 there, 5 times 2 would change this number to 10, and so now I have my 12 oxygens on the left side as well. So my final answer, I have a 1 to 5 to 4 to 4 ratio in the equation. One more example. This one is C8H18, which is gasoline, octane gas to be specific. We need to translate this one. C8H18 plus oxygen gas. Oxygen is a diatomic, so it needs a 2. Yields carbon dioxide gas, CO2, plus water vapor, which is just water, H2O. I know that they say gas here, and water vapor is a gas also. So if you want to be technical, we could put a little G or an up arrow next to each of these, and I guess I'll go ahead and do that now. They didn't specify this was a gas, so I won't do that. That's a gas, and I'll put G for this one. All 3 of those symbols represent the same thing. Alright, so I have 8 carbons on the left, only 1 carbon on the right, so I need an 8 in front of this carbon. I have 18 hydrogens on the left and only 2 on the right, so 9 times 2 would give me 18 hydrogens on the right. So we have 8 carbons and 18 hydrogens. 2 oxygens on the left. 8 times 2 is 16 plus 9 times 1 is 9 oxygens. And if I add these together, I'm going to get 25. 25 is an odd number. What times 2 would equal 25? Strangely enough, if I did 25 divided by 2, I would get 12.5. 12.5 times 2 does equal 25. However, I can't keep a coefficient of 0.5 as my answer. And so what I want to do to compensate for this is I'm going to multiply every coefficient by 2. And when I do this, I get 2 C8H18 plus 2 times 12.5 is, 2 times the 12.5 makes it 25 O2. 2 times 8 is 16 CO2 plus 2 times 9 is 18 H2O. And so this would be my final answer with a ratio of 2 to 25 to 16 to 18. That's my mole-to-mole ratio, 2 to 25 to 16 to 18.